Hi, I'm Symphoneers, and today we're taking a look at how to make Tunic-style foliage. That's to say, like, big, chunky stuff that the player can interact with and push out of the way, all in Godot and all without doing any coding. I just couldn't find a tutorial to quite do this exact thing, so once I figured out how to do it, I was like, oh, let's share the knowledge with people. Anyway, let's get into it. So, foundational thing required for this tutorial to work, you will need a player character that can exert force on the world, or like physics, do physics impulses on kinetic objects or whatever, physics objects, and push them around. Like move a crate or whatever, shove a crate. I don't know if this is a particularly good way to do that or whatever. This is the code I found by just like Googling how to do that and copying it over from Reddit. But yeah, this is code that you can use to do that. To put it after the move and slide in your player character. So moving on to the actual foliage, we'll need a rigid body 3D node, and this is going to be the basis of our bush, our foliage. And then we need a mesh instance 3D to give it a visual thing and a collision shape 3D. We want to make sure that both the collision shape and the mesh are attached to the rigid body. And for the mesh instance 3D, we will just go ahead and say, click on mesh and do new box mesh. And same thing for the collision shape, just to keep everything nice and simple. New box shape 3D for the collision shape. And pardon me, my project origin point is a little bit above the ground. Oop. Make sure that if you're moving this collection of stuff, you're moving the rigid body 3D so that all of it moves together and you're not like dragging the mesh instance away from the collision. That can be an annoying bug to troubleshoot. Anyway, so we now have this terribly exciting box that works with physics and stuff. Great. Cool box. In order to make this do some more complex behavior that we'll need for foliage, we want to add joints to it. This is not the final joint we'll be using, but I'm going to go ahead and add a pin joint 3D because it's useful for talking about how joints work. Joints attach to physics objects, and you can see there's a node A and a node B here. Let's attach one of those nodes to land, the ground in my project, and the other node to the cube we just made. I'm going to go ahead and rename that bush, actually, just while we're at it. The pin joint will update if you, like, change the name over here. And yeah, so the pin joint is currently inside the cube. Let's drag that up, and then start the project. Oh, it's stuck in midair, unless, actually, is it? Whoa! We can push the cube around. So the pin joint is one of the simplest joints in Godot. It will just kind of, joints will try to maintain the distance between the two nodes that they're anchored to. So in this case, it's maintaining the distance from the land, from the ground, and then it's also maintaining the distance from the cube. And then once you add impulses to that, it'll swing around and stuff. You'll also notice that it's kind of swinging for a while here. Godot's kind of default physics rely on friction and stuff in a way that can be a little bit awkward for this type of application. We'll kind of circle back to that. So that's a really basic kind of application of joints and physics bodies in Godot. If you try to use a pin joint to do a bush or something from the ground, it will be technically functional, but it will kind of like rotate around and stuff, and it won't maintain a sense of structure. Like this is suitable for maybe balloons or something, but not so much for foliage. So getting rid of the pin joint 3D, the thing we want instead is a, what's it actually called again? Generic 60OF, 6 degrees of freedom joint. So we create that as a child of the bush node again. And once again, we'll just assign each of the nodes on the 6 degrees of freedom joint, one to the land and one to the bush. And let's move that down between the ground and the cube now. Oh, pardon me. Let's actually move the whole thing down a bit here so it's a little bit easier for the player to interact with. And now, this is, pardon, don't mind my cell phone. This doesn't work. So the 6 degrees of freedom joint is one of the more complicated joints, and it, by default, does not move. To get it to actually flex and stuff, you will need to go into, for our purposes, angular limit, and we want the x angular limit, and let's say, I don't know, 30 degrees for the x angular limit, and the 30 degrees, increasing the upper angle for the z angular limit. That's going to be the kind of horizontal plane, basically. And once we up those angular limits, you can push it over. This is still not quite the behavior we want. So the big tricky thing, the big issue I ran into was I messed around with 6 degrees of freedom joints forever and ever with angular spring and stuff and could not get the behavior I wanted. Nothing really worked, basically. The thing that you need to do is to apply a physics force upward so that the bush will try to right itself. And that was annoying to me because I didn't want to code that. It's not even very hard to code, I just didn't want to. But we have a nice kind of easy, hacky way to do that, actually. And it's very simple, too. We just take the gravity scale of the rigid body and change it from 1 to -1. And that's helpful because the joint, remember, is going to keep the cube, our bush, tethered to the ground. But we can now nudge it around and it will actually try to right itself because gravity is pulling it upwards instead of towards the ground. And that's great. That is our, like, bare bones basic behavior handled, which is excellent. And yeah, again, the 6 degrees of freedom thing preventing us from, like, pushing it into the ground or whatever. It can be, the behavior and stuff can maybe not look quite right. The main ways that I have kind of dealt with that is by adjusting, I think it was the mass. You can tinker with the mass, you can tinker with the angular dampening, and, like, turn that up to, I don't know, 2. Linear dampening, let's adjust that up to 2 as well. And stuff like that will give you a kind of more natural shove. It won't, like, bounce around quite as much. It'll flex out of the way and so on. But yeah, it won't, like, snap and judder in the same way. So that's the basic behavior handled. Let's make it look a little bit more like a bush, just for fun. We're going to go into the material on the mesh instance 3D and create a new standard material and just go into the albedo of that material and make it, you know, kind of green-ish. Sure, good enough. And then, to get, like, a stem or trunk or whatever, we will just go ahead and make another mesh instance 3D. And we will make this a cylinder mesh. So a little bit big right now, a little thick. We'll just really quickly adjust the transform, once again shrinking the X and Y to like 0.4 or something, sorry, X and Z to 0.4, breaking the link so that we're not also adjusting the height of the cylinder. And then let's again go into the mesh, make a standard material, make the albedo color on this material brownish, or just like dark, yeah, something like this. And then yeah, because the cylinder we just made doesn't actually have any collision or whatever, we can nudge it. It doesn't like clip in a meaningful way with the ground or even the cube, and it will kind of make it look correct, or like make it look like this nice little tree shrubby thing that we can nudge, we can push out of the way. But yeah, and there you go, that's your kind of basic Tunic-style bush. We can convert this to a scene so that we can copy and paste it a little bit more easily. Just right click on bush and make click, pardon me, save branch as scene. and just go into, yeah, your like scenes folder. Whoops, I didn't delete the earlier version of this scene I made, and it's still open. So I'm going to save it as a just like new bush. Save, and then we can now drag new bush into the world. Where did second bush end up? It's down there for some reason. And yeah, this will also work. This will give us a nice, you know, little pair of bushes that we can wedge ourselves between and push through. And yeah, this is one of the reasons why it was... It might take some tinkering to get stuff kind of feeling right. Like, I would probably want them to be a little bit easier to push apart. Maybe use a slightly higher angular limit on the 6 degrees of freedom joints. But yeah, we do this. And yeah, we now have, you know, foliage that the player can cram themselves through. There's some exciting things and some like asterisks and risks to approaching foliage and environment design this way. One is that you can't change the name of your land or your ground after you do, if you make a scene and stuff and do it like this, because that will break, if not all the foliage and stuff that you have down, it will make any new foliage you place unable to, yeah, it'll throw 1 billion errors. It's easy enough to fix, but yeah, it will brick stuff. So that's a like risk to note. If for some reason you do find yourself in a spot where you've done that and that type of error stream is getting thrown up, you can actually just put in a new static physics object named land or something, and it will give them enough to function properly, essentially like an arbitrary point for the joint to work off of. So that is like a way to fix it if you find yourself, you know, in too deep and you've bricked it somehow. Just be sure that you remember the name of like land or whatever you are anchoring all of your foliage to. Other kind of risks and things are, I wouldn't want to do this, so traditionally this type of like foliage deformation is handled with shaders and stuff, which have a whole ton of like culling and performance things happening. We're using the physics engine to do this, and this implementation is pretty simple, pretty low risk, but I wouldn't want to do it with like very complex collision meshes or anything. I think it just like for the sake of performance and ease and so on, I think it works well with low poly meshes. The other thing I would kind of advise against, or like say is risky to do with this type of implementation, is to have them actually touching, like to have the green of the bushes touching. It's probably not like a big deal to just have a pair of them, I don't know, like clanking against each other or clipping or something. But yeah, they will actually deform out of the way. That's kind of fun. But the big problem with that is that if you are doing that a lot in your environment design and stuff, you're generating a ton of physics collisions without any player input, and you're making this like complex system that's just generating a ton of work for the engine without yeah, like any player input or like any gameplay payoff, really, or probably. So just be careful of like the environment design that you do while using this stuff. But I do think that this approach is kind of cool, or has some potential in general. I actually haven't tested if this works, so I guess we'll find out now. But one thing I thought of is like you can actually do more complex environmental design using this thing as like a foundational part. So you can have like a larger tree that is comprised of multiples of these things, and then you can have the player, well, maybe not like this, maybe not in this particular case, but yeah, you can use it as platforming for the player and stuff. The physics flung us really far off there, which is also another kind of like good thing to note. I mentioned tampering with the dampening and stuff on the physics body, or the rigid body 3D. Increasing the dampening and stuff will reduce the amount of kind of like player jank that this type of system produces. So yeah, if you're getting like big weird collision stuff happening, you might need to increase the dampening, make sure your gravity's set correctly. You can't do higher than -1 or the trees will fly away. Let's just demonstrate that. -3 gravity. Oh, or not. They were flying away earlier. Maybe I have the, it's because of how I have the pins set up now. They can fly away. Yeah, I don't know. Yeah. And yeah, I don't know, I was just excited to actually figure this out. Because yeah, I think it can allow for some very cool environmental design to have like a willow tree with pin joints and foliage hanging down, and the limbs themselves are doing this like flexing foliage implementation or something. I think this approach has potential and is not terribly complicated. Best for like bespoke level design and stuff. But like it doesn't scale as well as something like shaders and terrain painting does. But if you are making smaller levels and so on, I think it's neat. I think that's all the stuff I wanted to cover in this tutorial. Let me know if it was helpful to you. Let me know if there's other stuff you'd like to see. I am not an experienced coder or whatever. I'd maybe advise checking the comments to make sure, like, see if there's anyone saying, oh, this is an awful way to do it, or whatever, but I don't know, I felt this was simple and functional and stuff, and yeah, I wanted to share. I'm not terribly good at Godot, but I've gotten my dialogue system working better and so on, and maybe that's a thing to do a video on or whatever. I figured out like a low poly Blender to Godot workflow for terrain, so maybe that's a thing. I don't know, like, let me know if you want to see more tutorials like this, if you kind of prefer the style I've done for 1 or 2 videos in the past of, like, big chunky devlogs that are more of a post-mortem or whatever. Yeah, this was just, the negative gravity thing for this was so goofy and annoying, or just like, oh, of course, that I wanted to share it and try to, you know, save some time for folks. I forgot, like, subscribe, whatever, do YouTube things, help me know to do more of this, or like, numbers going burr, helps make more of this type of thing more likely to happen. Woo! Thanks for watching, hope you have a wonderful day, good luck with your game, and yeah, bye-bye. Thank you for watching the video, and an extra big thank you to the Patreon patrons and YouTube members that help make these videos possible. Hope you have a wonderful day, bye-bye.